I'm Isha Gupta, Marketing Manager here at Geometric, and I'm the host and moderator for today's webinar. Joining along with me is Prashant Chandanapurkar, who's a domain expert in the field of design for excellence at Geometric. So, like you understand, we've got a brand new release of DFM Pro 4.0 for our Creo Parametric users a few weeks ago, and we are really excited to show you the new features and modules available in this release today. So before we jump right into it, I'd like to talk a little bit about who we are and about the logistics for the webinar. So most of you who are watching this probably already know about Geometric, and for those who don't, we'll give you a brief background about our company. But before that, I'll quickly explain the functionality. Your active participation is important to the session. I have kept everyone on mute at this point of time to avoid any background noise. However, you can enter your questions and comments in the questions box that is available on the GoToWebinar console on your screen. We'll attempt as many questions as possible, that is during the end of the presentation. So with this, we'll quickly talk about who we are. Next slide. So Geometric is a world's leading solution provider with exclusive focus on the digital product realization space. Our services, products, and solutions are basically aimed at helping our customers make their product better, faster, and at a lower cost. Geometric is a public listed company with revenues of over 181 million USD in financial year 2015. Our customers are leading global automotive OEMs, aerospace OEMs, industrial OEMs, as well as their suppliers, along with other industry leaders in medical, high-tech, and consumer durables industry. And what really helps us serve these big customers is our strong partnerships and alliances, leading independent software providers in our domain, such as Dassault Systems, Siemens PLM, PDC Corporation, and ANARC. We have partnered with these ISPs to build a strong set of technologies and solutions that increase efficiencies in the design, manufacturing, and visualization space for our customers. DFM Pro is one of the solutions in our portfolio, and which is what we're going to focus on today's session. So with this, I will hand it over to Prashant to start the presentation for today. Over to you, Prashant.
Thank you, Isha. In next 30 to 35 minutes, I'm going to provide a brief overview about DFM Pro, how it is integrated in Creo Parametric, especially for the users who are joining it for the first time. And then I'm going to talk more about what are some of the new features, provide overview about them, and show a quick demonstration how designers can benefit by using DFM Pro into their design process. Before we go into the DFM Pro introduction, it is essential for people to understand what is DFM and DFA all about, and why is it so important to have DFM and DFA included in our early engineering process. Typically, if you look at the number of design changes or design iterations happening, we have found that more than 30% to 50% of the time which is spent goes into rework by a design engineer. Now, this time is essentially spent in various areas. Now, that could be like, example like drawing changes or drawing related issues. It could be even manufacturability related issues. It could be because of costing. And many times also it happens because of factors which are, really like changes in specifications from the client side and so on and so forth. But out of this, if you look at preventable changes, which really which really can be addressed right at the design stage. You can look at this graph which depicts that 24% of this arise out of the manufacturability, 40% from the error in part, geometry, a few of them 3% coming from mistake proofing or something to do with poka-yoke, or even 7% come from costing issues. So essentially, what it is important for design engineers is that if they are able to get this trigger early, or if they are able to understand what are the downstream requirements coming from manufacturing side, requirements which are coming probably from serviceability side, and all those stakeholders who are involved in process. So it could be, even in-house manufacturing or even suppliers. Then they can build into the solution and get early feedback about design changes, and essentially make sure that while they are creating the design, all these points or aspects are taken into consideration. Because essentially, if you do late stage changes in design, it's going to be not only leading to rework, but it's going to be very, very expensive. For example, if you have already invested, if your supplier has already invested in tooling, and then you go to a supplier and say that, hey, I want to change my design, then all the tooling which has been done by supplier has to be scrapped, and that cost supplier is going to charge you. So it's not just the time which is important, but also the cost or even issues which comes because of the quality are equally important. Similarly, more from the business point of view, if you typically look at now on the chart which is there on the right hand side, talks about, if you look at the x-axis is more about time, and y-axis is about the money part of it. Then you have the cost, where a business is investing for creating design, creating new products. So that goes as initial cost of development. Then you go through a product launch phase. Then the product goes through maturity. You have the revenue which is earned, and then typically, if it's a consumer product or a durable product, then you have a stage of decline, and then you actually phase out the product where you have end of product life cycle. Now, typically when businesses go through the process, the blue line is essentially what it is planned, where you say that, okay, I'll invest so much and I'll have so much revenue, I'll make profit out of it, and that's how you make the business case. But in real world, what happens is that whenever you have scheduled your project into certain timeline and you have delays, then your timeline shifts here, and you can see here the red area here indicates the additional cost burden a business has to take for development of this development of the new product. And on the top here, what you see is essentially that because of the competition in the market, or because of the delay, you have order cancellation, you essentially suffer revenue loss. So here, your business actually has more cost than the plan, and then you have less revenue than the plan. This would lead to what we typically call as impact of delayed product launch, where you not only suffer on your revenues and cost, but overall impacts the business profitability. So it is very, very important for businesses to understand that it's the productivity of the engineering process, and it's also how it impacts overall business. And that's why it is imperative that all those requirements where you start doing commercialization of the products, all these requirements should be addressed right there at the beginning of the DFM, at the beginning of the design process. So with geometric DFM Pro solution, this is what we are trying to address as a problem. What we have done is that we have captured or collected various industry-specific best practices. These are, engineering best practices based on, again, different handbooks, guidelines, some of the key consultants who talk about it. There are documents which talks about different standards based on materials. All these best practices, what we have captured in form of a database. And what we also do is that we help you to capture your specific organization-specific best practices, which are again coming from even functions like manufacturing, sourcing, and services. This is what we captured as organization best practices, and we take these best practices and convert them in form of what we call as a rule. So a rule is nothing but a check or a validation process that goes here as a database. And when the designer is designing a product, DFM Pro does two things: that it provides a feedback to a design engineer in terms of what is not meeting those design criteria, what is not meeting those best practices or guidelines. And what it also does is that it provides suggestion to a design engineer how that issue or problem can be resolved or handled. again, while doing this, our key focus here is on three areas. Is that how do we ensure that we do the knowledge capture within the organization? And here it essentially means your best practices or your guidelines. Second part is how we help to improve the engineering efficiency. And third thing is it helps ultimately to reduce the rework which happens during the process. And as I said earlier, that if it's a earlier rework, while it's still in design phase, it is much cheaper, it's much easier to do than when it happens from manufacturing and servicing. Like, to give you one example, it's like we always see in case of automotive industry that cars are being recalled and that there are issues with the quality and all. So this is an extreme case where issue is very difficult to detect manually, even at times of manufacturing. But then your product goes to a field, and then you have failures or issues, and that's why you have recalls, and that leads to huge cost and impact, and many times it impacts the overall image of the organization. So what we have done is that, as I mentioned, we have more than 150 global best practices which are captured. These are coming from various processes like machining process, injection molding process, that is typically plastic injection molding process, assembly. Here it applies to both the mechanical assembly or even mechatronics assembly. There are also modules, separate modules for even processes like additive manufacturing, which are upcoming, or new processes like additive layer manufacturing process, processes like casting, and processes like sheet metal. So these are checks which are already built into DFM Pro. But what we are now trying to do with each and every release, we're not only adding just the additional functionality and functionality, but we are also adding some of these new rule checks and module with every release. So with this specific release of 4.0, we have the traditional process like sheet metal, injection molding, and milling, wherein we have added a few rules. Like, for example, here in case of call sand casting module. Followed by that, we have a module which is about investment casting, and also a new module which is related with process called tubing. So these are some of the modules which we have now added to the DFM Pro version 4.0 for Creo Parametric. And again, we have also added support for the latest version of Creo Parametric, that is version 3.0. So currently, if you look at, we are supporting all the versions which are PTC Pro Engineer, Wildfire 5.0 onwards till Creo 3.0. Now I will move into details of some of these checks, how we are trying to address these problems and what are typical issues. So the new module what we added this time is the tubing module, and what we are essentially trying to check here is that we see that tubing is a critical process in industry. Many times tubing is used for conveying fluids. Tubing is also used many times as supporting structure. And the key process here for tubing is that what we call the bending process, that tubes are often bent and they carry either fluids or some of the times some wire harnesses from one point to another point, and also they act as casing in many ways. So there are various applications of tubing, and essentially, if you don't adhere to this bending radius, what will happen is that either there will be deformation. So what is happening here in case of a bending process is that there are compressive forces playing here on the inner radius, and on the external radius of tubing during bending process, it is going through expansion. So it could lead to at times cracks, at times develop thin areas, and this could lead to a lot of leakage, performance loss, and many times at short service life. So typically a guideline for tubing, bending of the tubing is provided that tight bend should be avoided or sharp bend should be avoided, and it should have a specific or given radii which is predefined for various bending processes. So for tubing now we have provided this new rule which is about bending, and I'm going to further demonstrate it in my demo. Similarly, we have added processes. Now in case of casting, we have new process called investment casting. We also have process like sand casting, and we have also the generic casting process. Now, typically, if you see this component here, it's a investment casting, and investment casting is used pretty commonly where you have part profiles which are which is very complicated, and in such cases it's very useful. One of the checks what we are doing with investment casting is typically the check for wall thickness. It is very critical to have the minimum wall thickness check, especially for investment casting, because this again lead to a lot of issues during manufacturing, which is caused by porosity in the material, which is caused by a non-uniform flow of the material, and this could lead to again leakages and performance loss and short service life. And the check here is about how do we ensure that minimal wall thickness is as per the desired guidelines of the process. One more example here. Now this is more relevant in case of a pressure die casting process. Is about mold wall thickness. So the parameter essentially is that a mold wall thickness should be greater than the specified value. If this condition is not adhered to, then what it will lead to is called as thin steel condition, or mold wall would be too thin, and that would lead to issue of lower life of the mold, and also it will create hot blade condition, and it will lead to differential cooling, and that has severe impact on even cost or the life of overall tooling. So here the guideline is that the mold wall thickness should be adequate as per the prescribed standard, and that's what we are trying to check about casting process. One more new rule we have added, which is in case of injection molding or plastic injection molding, wherein we are trying to verify the draft angle for ribs, and the check here is that the draft angle for the rib should be specified within the user specific range. So here what happens is that if adequate draft is not provided for the rib, then it gets tightly attached, and often removal of the part from the mold is very difficult. At times, if these are the two surfaces and it's doesn't have any draft, that would lead to poor surface quality. Many times it creates scratches, and overall it could at times also damage to the part if it's too thin. So the general guideline for this rule is that the draft should be 0.5 to 1.5 degree. One more rule what we have added is around sheet metal. This is pretty interesting rule. What we are trying to find out is that what are the areas which are leading to interference in flat pattern. Now, for typically sheet metal components, if you see that there is a blank or a plate, and from that plate the manufacturing person has to define and cut out various features and then start the bending process. If the flat pattern here, but you can see that if I make it flat, then these two plates will interfere, and it is not possible, or if it is not feasible to manufacture part like this. Many times then in such cases, if these features are required, then you have to probably get these two parts together and have a separate weld. But this is a serious issue in case of many times for sheet metal manufacturing, and it cannot be done on standard sheet metal manufacturing process or bending process. With this, I'm going to now quickly demonstrate. First part would be how a designer can use DFM Pro. So this is more to do with users who are going to use it for the first time, and then I'm going to walk through some of the new checks and capabilities what we have added. We have added in all total 90 new rules, but I'll not be able to go through all 19 rules, but I'll probably show some key rules and demonstrate how it works and how designers can use DFM Pro. So as you can see it on my screen, I have opened one of the sheet metal component, and you can see various features: holes, slots, bend, hems. In terms of usage, designer has to just click on DFM Pro and say start DFM Pro, and there are only two inputs required from design engineer. One is that what is a rule file here. So rule file is nothing but a collection of different rules or checks. So here for now I'll select one rule here called DFM.sm. I'll come back to this configuration, but this is something which is already predefined or configured as per organizational best practice. I select process called sheet metal, and then I click the run button. The system will automatically read a material which is specified. So for example, for this component, the material specified is 6061-T6. This is the aluminum alloy, which has already been specified in the CAD file or ProE file, and then DFM Pro will take it or read it from the material data, and the designer has to just click OK. Geometric has its own patented technology called feature recognition, through which all such manufacturing features like slots, bends, hems can be automatically identified, and based on that it will provide feedback to a designer. So you can see here now the analysis is providing feedback here in terms of crosses. The red crosses are the one where it is not meeting those criteria, while the green and the blue crosses are the one where it is meeting those criteria. So if I click here on the root node, it will show me further information about those inputs. So for example, here it is highlighting recommended flange parameter, and if I click here, it will highlight that particular flange. I can go to DFM Pro options and say zoom to fill instance, and if I click that instance, it will automatically zoom to that particular bend or that particular feature. So you can see here that the system is highlighting on the screen. So here this bend is highlighted, and DFM Pro provides feedback that here the actual value for inside bend radius is 1.6 mm, while the recommended value for inside bend radius is 1.8 mm, which means the designer has to change this value of bend radius to ensure that it's it's manufacturable. If a designer doesn't understand what this check is about, you can click help, and it provides further help, which talks about how the flange parameters are defined in terms of the height, in terms of radius, and in terms of thickness of the sheet. And it's then very easy to understand what this check is all about. So even for organizations, it's it's very easy to consolidate all their knowledge base into a single help file and configuration file. Similarly, there is a check called bend relief, and you can see here, as soon as I click, it highlights this particular leaf and shows that there is not enough bend relief provided. Typically during sheet metal manufacturing process, a bend relief would be required to ensure that the bending process is much easier. And I'm now going to show this third check, which I talked earlier about, called interference in flat pattern check. And you can see here DFM Pro highlights what is the issue here. So you can see very clearly with this highlighted area in the red and green that here if I make the flat pattern, this area, this flat, is greater than this area which is created as cutout, and definitely it is not possible to generate this kind of a feature. So what designer has to do, so DFM Pro highlights this as one of the flat which is not meeting the criteria. As a designer, I can go here and change this value to meet the criteria. So I go here and change the value, and if I now run this check again and I save the model, and you can see that now the values have changed, and you can see here the interference in flat pattern is still active. If I do validation again, I'll just make the run. And in a situation where these kind of issues are highlighted, a designer has to go through systematic elimination of each and every check. There is also a possibility that in many cases where the designer has to follow certain features. So you can see here now that the interference in flat pattern rule has gone as a rule passed. So this way, I can very quickly go and identify what are different DFM, DFA issues without even going for sitting with review with manufacturing or review with supplier. I can, as a designer, I can understand all this issue and resolve it right when I'm creating the design. Similarly, many times a designer has to eliminate or have certain features which are required more from the process point of view, or many times from the functional point of view. So here, for example, if a designer needs a particular bend, let's say, for example, let's assume this case that though this is not possible to manufacture, the designer believes that the value required for inside bend radius is still 1.6. I'll right click here and say ignore that particular instance, and then I can ignore that instance. Similarly, I can take particular instance and make it ignore all similar, and those instances will be filtered out, and these filtered instances will be stored here as ignored instances. So you can see here those instances are stored as ignored instances. Going forward, as a designer, if I may want to have certain reports based on probably I have to carry some of the reviews and have a review with manufacturing, I can right click and press Control I. As soon as I press Control I, I can take a snapshot of this and say that okay, the inside bend radius is 0.25 and that is required. So in such cases, even I can have the override and take snapshots and add such instances to the report. Again, I take Control I and say that okay, this is difficult to manufacture, and such instances can be very easily stored in form of report. So let's say if I finalize my design, I've taken care of all such instances, then I can generate report and store that report as a part of my repository wherein I can refer to those reports. So here is one example of typically HTML report where it captures the image. It has all the parameters which have failed. Those are captured here. I can similarly, as I was mentioning, I'll capture it in form of a spreadsheet. So here the spreadsheet will have number of rules, how many failures, and similarly I will also have a snapshot captured here. So you can see here the snapshot what I captured earlier is available with actual comment. So here I can have the comment and also the snapshot. So this way I can generate various types of report. I can also have a e-drawings or a 3D report wherein all those instances are available, and I can further collaborate with manufacturing or suppliers without sharing the original CAD file. So for example here I can put a comment and say change flange parameters, and those instances can be stored, and I can just exchange this file and invite feedback from various stakeholders from design and from design, manufacturing, or from supplier side. So this way there are some more new checks which are added. I'll probably walk through a few more. So I'll select a different rule file now. I'll select a sheet metal again, and I'll run through those checks. And the system is now again identifying. Again, you can have different type of rule file configuration based on your requirement, and the system will provide feedback in terms of how many rules passed, how many rules failed. So you can see that there are other rules which have now passed. There are different rules called minimum bridge height, a bridge angle. I'll go to help and I'll pull out those rules. These are the new rules what we added. So you can see that we are checking here the bridge height, similarly checking the bridge angle for the process, for the sheet metal process, followed by minimum bridge width. So this is about the bridge width or bridge related features. You can also go and select here in the beginning, go to the rule file editor, and these are some of the new checks which are added for sheet metal process. So there are checks which are related with bend relief, bridge angle, minimum distance between notches. So here again what we are configuring is that what should be the minimum distance between notches, and you can see here the check which is related with notch parameters. So the guideline here is that the distance between notch to sheet thickness should be equal to or greater than value of 2. So here essentially we are trying to check the ratio. Similarly, there are checks which are related with checks which are related with flange parameters and also enclosure size. So here you can define the recommended enclosure. This is again very useful during the manufacturing process. Now, what happens is that if the enclosure is formed such that the Y value is greater many times than the prescribed Z value, then this condition would arise. What you see here in the red cross is that the part will actually go and hit the tool, and this could lead to the damage to the sheet metal or even damage to the tooling. Now this should be avoided based on the flange height, and that's what we are trying to check here with the enclosure size. And you can see the parameters here, the Z parameters and Y parameters. You can configure all these parameters based on your requirement. So with this, I have covered few examples which are from the sheet metal side. But apart from that, as I mentioned, we have some new processes added. So I'll cover some of the new processes as well. So this is related with the tubing process. If I refer to a standard tube here, you can see this is a tubing which is meant for carrying fluid. The workflow remains the same, and you can see here the new design process called tubing process. I refer to a tubing process, and I hit the run button. And if there are any areas which are not meeting the standard bending criteria, those would be highlighted. So here you can see that there is a tube bend. DFM Pro will automatically calculate that the tube diameter is 10 mm and center bend radius is 25 mm, and the recommended value for center bend radius is 35 mm. So this way it's very easy, especially for processes like tubing, to identify if the bending is adequate or not, or if it is excessive bending, DFM Pro will highlight. And similar to other rules, then this rule can be also very easily configured. So you can see here the tubing process, recommended bed radius. You can also add various diameter values here. Typically, this question has been asked many times. What is the difference between the tubing and piping? Tubing is essentially where you consider the outer diameter, while piping is something which we use for calculation of inner diameter. So here it's a tubing process where the outer diameter is considered, and you can see that you can configure various values for tube diameters and recommended radius values. Also, there are some additions which are on the side of sand casting process. So here I have opened a component that needs to be sand casted. Select sand casting and just launch sand casting as a process and hit the run button. So you can see the workflow is pretty simple for all such checks, and it will show me what are the areas which are not conforming with this rule of uniform wall thickness, and it will identify all those areas where uniformity of wall thickness is not been adhered to. Again, it is important to understand why uniform wall thickness is required, because in case of sand casting process, especially, there are a lot of issues like formation of hot spot, areas which leads to uneven cooling, and if uniformity is not followed, this also means that you essentially tend to have more material than required. So that could make your part much heavier, and you are losing the material. And many times, let's say if it's a component in automotive industry, which means that you are carrying excess weight, and you are also impacting the overall efficiency of the system. Again, few more checks, which is with the process, what we call the investment casting. And here there is a check which is also been added for a process for investment casting. I'll select investment casting and hit the run button. And we are trying to check the minimum wall thickness. So you can see that here it is highlighting one case for minimum wall thickness. And if I zoom it, you can see that there is a hole here from the top, and it is forming a conical surface here at the bottom, which is leading to issues. And you can see the actual value of wall thickness here is 0.15, 0.5 mm. So this is a very, very thin area or thin section. If I go to a sectional view, you can also view it as a section. And you can see that this leads to a lot of problems like cracking or leakages. Again, what I've tried to do is that I tried to cover very quickly various modules and processes. But if you want to know more, you are definitely free to contact us, and we'll provide you with more information. Since we are running out of time, I'll ask Isha to step back in, and with that, I end my demonstration, and we would be really happy to provide you further information. You can write to us at info@dfmpro.com. If you would like to evaluate, you can have evaluation version to be downloaded from www.dfmpro.com. That is what our website is, from where you can download. So, Isha, over to you.
Yeah, thanks, Prashant, for the presentation and demonstration. We could cover it real fast, but I hope it was useful enough for all attendees. So I think we'll quickly move on to the question and answer session now, since we're really short on time. I already see a few questions coming in. We won't get to all of them, but we will try to answer as many as we can in the next few 10 minutes. Okay, so Prashant, the first question is it possible to save analysis results?
Yes, I mean, one of the functionality I forgot to mention is that DFM Pro also has what we called is import and export facility. So wherein, let's say, if I want to conduct the analysis and save my results and review them later, I can just run the analysis and save it as an export file. And next time when I want to refer it, I can again go back and import those results and view those results. So yes, it is possible to do the same issue.
Okay, thank you. So next question, how many rule files can be created?
Well, theoretically, there is no limit to how many rule files you can create. Rule file is nothing but set of different configuration of rules. This will again depend on different type of divisions or users where you would like to deploy. Just to give an example, let's say if you are in automotive kind of a company, there may be some checks which are for casting or machining for powertrain division, and if you are from let's say plastics or interior, then you will have different checks which are for plastics, and then you can have only those set of rule files created for different users. So theoretically, there is no limit how many rule files you can create. You can have it based on your department or organization setup.
All right, I hope that answers the question. Next one, can I upload assembly and check all parts?
So currently for processes, like for example, sheet metal process, and I'm hoping when you, what you mean by assembly here is that and not the assembly checks, because we already have separate assembly checks for clearance, interference, or fastener accessibility. Those are typically the assembly checks. But for processes like, for example, sheet metal, you can have your own sheet metal assembly, and you can load the sheet metal assembly and check all the parts which are meant with sheet metal and have sheet metal analysis done. But for processes like plastics and all, where you need to provide further inputs like pulling direction and secondary pulling direction, in that case, it is not possible to do the analysis on the whole assembly. So you have to go it part by part.
Okay. Now let's take a few more. How much time it takes for the analysis to run?
Well, time for analysis will essentially depend on type of part geometry, how many checks are there in the process. So I would say there is no straight answer to it, but generally we have seen it that it depends on the checks, but it varies from few seconds to even few minutes as well, depending on complexity of the part and number of checks.
Okay, so here's an interesting question. How about analyzing imported files from other CAD? by CAD, I think CAD platforms, and will it work?
Yes, I mean if you are importing dump solids like step files or IGS file, and if you are able to open any file which is in Creo Parametric, you will be able to do the analysis. However, many times I would say that the parts which are imported may not have certain information like material and all, and that may have to be selected manually. But yes, it is possible to do DFM or DFA analysis based on standard values.
Okay, so I think we're almost on time. One common question is coming across is, will this be available as a recording? Yes, the webinar would be available as a recording early next week on our website. We will definitely send you a link to the recording on our website somewhere around early next week, Monday, Tuesday. So I think, Prashant, we are almost on time with this. We would like to close this session, but all the remaining questions, we will save out those for responses over email. If you have still further questions, you can write to us at info@dfmpro.com. So another thing which I would like to mention here is that we would be participating at the upcoming PTC Live Global event in Nashville, Tennessee on June 7 to 10. And if you're planning to attend the conference, then please do visit our booth number 203. We also have our customer Honeywell who would be presenting about their DFM journey at the conference and talk about how they implemented DFM Pro and best practices. It would be a really insightful presentation, which if you're attending, do attend this presentation. The details of which are actually available on the PTC Live website, also on our website, www.dfmpro.com, on the event section. So this is about the PTC Live. So with this, we would like to close the session, and thanks again, everyone, for participating. Have a good day. Bye-bye.
Thank you.
Thanks.